Okay, now let's look at another concept involving a line. So here we want to let f be defined on some interval I, whatever, could be open, could be closed, as long as it contains some point x equals a. So the instantaneous rate of change of f at x equals a is the slope. I'll use this notation to denote the instantaneous rate of change. So f IRC of a is just the slope of the tangent line to the curve f at the point x equals a. So the main difference between instantaneous rate of change and average rate of change is this key root word here, namely the root word instant. So average rate of change takes place over an interval, right? So starting at A, stopping at B. The instantaneous rate of change takes place at a point, at the instant, where x is equal to a. So that's a fundamental difference between average rate of change and instantaneous rate of change. One of them is a secant line connecting 2 points. One of them is a tangent line at a single point, so at an instant. Just a couple of quick pictures so we can illustrate the difference between average rate of change and instantaneous rate of change. So here is a picture showing the average rate of change. So the average rate of change on the interval from A to B is just the slope of the secant line connecting these 2 points, A comma f of A and B comma f of B. So the slope of the secant line connecting these 2 points. The instantaneous rate of change at the point x equals a, so now there's no interval, now we're just at a point, it's just the slope of the tangent line to the curve f at the point a comma f of a. So again, there's no interval to work with here, we are just looking at the tangent line at the instant where x is equal to a. Okay, now we want to compute the instantaneous rate of change of the function f of x equals x squared, and we want to find that at the point where x is equal to -1. So we're looking for the slope of the tangent line to the curve x squared where x is equal to -1. So we don't really have a good way of doing that yet. We don't have like a formula like we did for the average rate of change. So what we will do is to compute successive average rates of change. So for example, we'll look at the average rate of change from -1 to 2, and then we'll take 2 and move it a little bit closer. So then we will look at the average rate of change from -1 to 0, and then we will look at the average rate of change from -1 to -1/2, and then we will look at the average rate of change from -1 to -0.9, and then we will look at -1 to -0.99, so on and so forth. Okay, now to compute the instantaneous rate of change of this function f of x equals x squared. So we want the instantaneous rate of change at the point where x is equal to -1. And so what we will do is to compute a bunch of average rates of change. So the first thing we'll do is to look at the average rate of change on the interval from -1 to b equals 2. So that's going to be our right-hand endpoint. So we saw before that the slope of this secant line connecting the point -1, 1 and 2, 4, we saw that that slope was equal to 1. And remember, that's just f of 2 minus f of -1 over 2 minus -1, and that just reduced down to +1. And so now we want to take this right endpoint and move it closer to the left endpoint. So let's move 2 to 0. So we'll take our new right-hand endpoint to be 0, and so now we want the average rate of change from -1 to 0, and so everywhere I see a b, I'll just write 0, and so you work all that out and you get -1, just the same way we did here. And you do the same thing for all the rest of these, right? So when b is equal to -1/2, just plug in -1/2 here and here, work out that fraction like we did up here, you get -1.5. Here, when b is -0.9, again, plug this into the average rate of change formula, work it out like we did the previous 3 cases. Here you get -1.9. Do the same thing when b is equal to -0.099. Here you get -1.99. And so we can make a guess that if b is equal to -0.999, then the average rate of change there. So when b is very close, so -0.999, when we look at that average rate of change, that is essentially the tangent line. And so there we would get that the slope is -1.999. And so now we're ready to make a guess that the instantaneous rate of change based on this table of values, we can guess that the instantaneous rate of change then is -2. So we're going to make the guess that the instantaneous rate of change at -1 is -2. Just a side note on computing these quantities using a calculator. So we could take the value for b and plug it directly into this thing. That's what I did here in the first 2. But notice here you can factor the numerator and cancel the term in the denominator, and here we would get b minus 1. So really, instead of using a calculator to compute this quantity, I can almost compute this same quantity just by inspection, right? So you can see when I plug a 2 in to this thing, I got 1. But I could have plugged a 2 into this thing, and that would have been much easier to see that we get 1. And for example, here, if I plug in -0.99, well, when I plug it into this thing, the computation there would take more computing power, more keystrokes, if you like, than if I just plug -0.99 into here. And you can clearly see when I plug in -0.99 into here, I would get -1.99. So sometimes a little bit of manipulation can make the computation much, much easier.